Welcome! Today we're going to do a deep dive tutorial on a really fundamental design pattern for working with large language models. It's called few-shot prompting.
So as engineers, I'm sure we've all been there, right? You're trying to get consistent, predictable outputs from an LLM, you're building systems that rely on these really clean data handoffs, and when an AI's output is even a little bit ambiguous, your whole pipeline can just break. Well, this technique is an incredibly powerful solution for getting that control back. All right, so let's break this down. We're going to start with a really precise definition of the pattern, just so we have a solid foundation for everything else we're going to cover. At its core, it's all about showing the model exactly what you want it to do through demonstration. So instead of just telling it what to do, you're providing a few high-quality, concrete examples. You're leveraging its powerful in-context learning ability to basically grasp the specific pattern you need on the fly. And this slide really highlights a critical difference, especially when you compare it to the more basic zero-shot approach. You see, with zero-shot, you just give an instruction and you kind of hope the model's general training is good enough. But few-shot adds this crucial layer of explicit guidance. You're actually demonstrating the specific input-output pattern you expect. So, what's the mechanism here? How does this actually work at a conceptual level? Let's build a really simple mental model to understand what's going on under the hood. The easiest way to think about it is this. Each example pair, so an input and its corresponding desired output, it's like a flashcard. You're basically preparing this small, custom study guide for the AI, tailored specifically to the task you need it to do. So when you put these examples into the prompt, the model's attention mechanism gets to work. It starts analyzing them to figure out the relationship between your inputs and your outputs. Now, it's really crucial that these examples are not just high quality, but that they're also diverse enough to teach the underlying pattern, not just getting the model to mimic you. This is what keeps it from overfitting to just your examples. It learns the format, the style, the logic, and then it applies that freshly learned pattern to the new query that you give it at the very end. Okay, theory is great, but let's make this concrete. We're going to look at a classic sentiment analysis task, but one where we need very, very specific output labels. Just look at the structure here. We're not just telling the model, hey, classify sentiment. No way. We are showing it precisely how to handle a clearly positive case, a neutral one, and a negative one. And notice we're also defining our exact output labels, positive, neutral, and negative, all in caps. By providing these examples, we're actually constraining the model. We've taught it our specific classification rules right here in the prompt. So now when it sees that final, more nuanced review, the one with both positive and negative things in it, it is so much more likely to follow the pattern and give us a reliable, well-formatted classification, instead of just some long, rambling answer. And now for the really crucial part. How do we apply this in a real-world engineering scenario? Well, forcing a specific JSON output is a perfect and honestly a very common application. I mean, think about it. If an LLM's output is going to be the input for another service, maybe an API, maybe a database entry, you absolutely cannot have any ambiguity. The structure has to be perfect every single time. Otherwise, your system just won't work reliably. The process here is super methodical. It follows 3 really clear steps. First, as the engineer, you define the exact JSON structure you need. Second, you demonstrate that structure with at least one complete example right in the prompt. And then finally, you provide your new text and ask the model to apply that pattern. And this slide right here gives us a practical, just ready-to-use template. We're providing one complete, simple example that shows the input text and the perfectly structured JSON output. Then we give the model new text that's a little bit more complex, right? It contains some irrelevant information, like an address. The model now has to understand its goal isn't just to extract information, but to format it into this exact schema and ignore all the noise. So look, if you remember just one thing from this explainer, let it be this. For precision tasks that require reliable, structured outputs, demonstration through examples is so much more powerful than instruction alone. You have to show the model what success looks like. And this leaves us with a final thought. Few-shot prompting isn't just for simple formatting. You can use it to teach logical reasoning steps, or very specific coding styles, or even complex data transformations. The potential here is just vast. So the real question is, what new logic are you going to teach?